Hello, everybody. My name is Dušan Čenejac, and I'm one of the communication managers from the VALPRO Path Project. And I want to welcome you today to our webinar, How Can Nutrient Tracking Inform Consumer Food Choices? Insights from the VALPRO Path Project. I'll be for just a couple of rules that this webinar will be recorded and it will be later used in the VALPRO Path social media channels. And that if you have any questions during the webinar, please use the Q&A option below. And once our session Q&A starts, we will be asking the questions to our speakers. Now to share the screen. Okay. First, what is the VALPRO Path Project? We are a Horizon European project that spans 4 years from the September 2022 until August 2026. We have 22 partners from 9 different countries, and we are actively developing fresh possibilities, validating and showcasing ways to enhance plant protein production for food and feed in the EU. Our crops that we are focusing on are lupins, soybean, chickpea, lentil, peas, and fava beans, and our we are doing this for our innovative production systems or our living labs that are located in Germany, Ireland, Italy, Portugal, and Denmark. Our main focus is for driving economic growth and social welfare in line with the European Green Deal. Our speakers for today are Dr. Ricardo Alvarez from he's a food scientist and research officer for the VALPRO Path Project at Teagasc, and Teagasc is the national body providing integrated research, advisory, and training services to the agriculture and food industry and rural communities. And our second speaker is Dr. George Kyriakarakos. George is an agriculture engineer and a senior research associate for farmB. farmB Digital Agriculture SME connects researchers with practices offering IoT and AI solutions that use data from sensors, drones, pest traps, and more for holistic agricultural assessments. What you can expect from our webinar will be insightful presentations on how nutrient tracking supports sustainable food production, focusing on plant-based proteins and digital tools for data analysis, a dynamic discussion addressing challenges and solutions in adopting nutrient tracking technologies, featuring experts from the VALPRO Path Project, and knowledgeable takeaways on how advanced nutrient analytics shape better decisions for producers and consumers in the plant-based sector. Now I will be Dr. Ricardo Alvarez will be taking over and explaining what is nutrient tracking. Dr. Alvarez, you can continue.
Okay, thank you very much, Dušan, for that introduction. Let me just share my screen. Okay, so the talk that I will be giving today will focus on tracking protein in plant-based food supply chains from field to farm to develop a modeling tool that we aim to use for optimization of the supply chains in order to make processes that are more sustainable. I will also present a case study of using drones for nutrient assessment in the field. But before going to those 2 examples, the modeling tool and the drone utilization, I want to explain you why we are doing this field to product nutrient tracking. So the main reason is because with a nutrient tracking tool, we can inform consumers about where the products come from, and through a transparent traceability and sustainable sourcing practices. Also, the data that is gathered in the nutrient tracking tool can help to make decisions on how to make the processes more sustainable. And at the same time, we can observe what nutrients are going to the waste, to the side streams of the process. So we can revalorize those side streams in order to drive process to circularity. And the way that we are doing this in the VALPRO project is by a series of 3 steps. The first consists of mapping the supply chain. So this means identifying every step along the chain from the farm all the way to the final product. For this presentation, I will be focusing on the production of a plant-based beverage. After mapping the supply chain, we collect the data. By data, I refer any quantitative number that we obtain. It could be the yield in the farm, also the yields during the protein production, plant-based protein production. So everything that that is produced, but also we take into account the amount that is lost, the side streams. And at the same time, we are using near-infrared analytical tools for field and nutrient analysis at the farm level. And these tools consist of using satellites, drones, as I will be explaining in the coming slides, and also portable handheld equipment to analyze the crops. So once we have mapped the whole chain and gather all the data, then we use all that to create a model that simulate the whole supply chain. We aim to use this model to simulate the process and predict outcomes. This in order to see where we can enhance or optimize the production for increasing yields, reducing waste, but also importantly at the farm level to find out how we can inform the farmers to improve their practices to make a more sustainable farming system. So this is the main idea behind the nutrient tracking in the VALPRO project. So now I will move to the case study of how we are using near-infrared drone technology to enhance protein yields for a more sustainable plant-based beverage production. So we're using drone technology equipped with NIR because we can scan the fields in a very accurate way. By accurate way, I mean to the spatial accuracy. So the drone gives us a precision of centimeters, so we can locate areas very accurate with the drone. And the benefit of equipping the drone with a NIR sensor, in this case it's a NIR camera, is that the camera will detect details that cannot be detected just with a simple eye. So as you can see from the video that are playing right now, we have a video of a regular camera that is a RGB, but we also showing the NIR camera that is on below, and we see how things are different. So this difference allows us to detect the stress, if there are crops stress, and if they are, we can take corrective measures to improve their health. So just a bit more behind the technical part of how the detection of the crop with the NIR camera works. So we have plants that when they are green, we assume they are healthy. And the plants, when they are less green, going more like to the final stage of their life cycle, they're more brown, so they are less green. So the light that they reflect is different. Those that are quite green, they reflect light in the spectrum of NIR in a higher way than those plants that are in their final stage of their cycle. The light that they reflect is lower. So the camera can detect these different patterns of reflection of light depending on the stage of the plants. And then what is called the normalized difference vegetation index can be calculated. And this index is how we can differentiate between a healthy plant or a plant that is stressed or area where there's not a lot of plants, so a scarce area of plants. So based on this index, we can detect in the field the state of the plants. So we can build maps of the health status of the field. For example, in this image, again, I have on the top what is the image of a farm just using regular camera. So the RGB. And on the image below, I have the same farm, but the map that was built using the NDVI. And we can observe that in the NDVI, we have different shades of green, meaning that the health status of the plants varies according to different areas. So this makes more easy to detect areas where the crop might be stressed, and we can take action. Now, the reason what we are interested on using the drones is because the NDVI most likely has a correlation with the protein content of the crop. It is assumed that the healthier it can have a better development, so the nutrients are higher. So we have tested this in a field. Here I put an example of a field where we have two areas. So area A and B. Now these two areas have different crop systems. And we took samples of the areas that the drone detected as good health and healthy plants, and areas where the plants were stressed. So I point out the points in green where are the healthy points, the healthy plants, and in red, the areas where the points where the plants are more stressed. So we mapped this with a drone. We went to the field, to these specific points, took samples, measured the protein, and also the yield. And from the yield, as you can see from the figure in the right, we see a tendency that shows that the more healthy the plants, the higher the yield compared to the stress, which they have lower yield. And this makes totally sense because the areas where we have more green, it means that plants are growing and there's more amount of plants on these zones. Contrary, on the stress areas, plants are not growing very well. We'll have more limited amount of plants, and that will yield to less amount of crops as well. Now, interestingly, when we look at the protein content, that tendency was shift. So we observed that the points where stress plants were present have a higher protein content than those that are in a healthy point of plants. And this could be explained based on the fact that in the stress areas, we have less amount of plants. So the competition for the nutrients from the soil, it's lower compared to the competition of healthy points where we have a lot of plants. So by having more plants, the competition is higher. So the uptake is reduced. And that's why we observe that the stress points have higher protein content, basically just because there's less competition for the nutrients and they can develop a higher protein content. Now, we have to be careful of how we interpret this data, because one might say that it's better to have a scarce area of plants. But when we calculate the amount of total mass of protein based on the crops and the protein content, it means just making a simple multiplication of those two parameters. We observe that healthy areas will yield a higher mass of total protein. So the amount of protein that can be obtained from those points are higher on the healthy than the stress. And this is important because then the drone can help us to detect the areas where are stress, and actions can be done to reduce those areas of stress for crops. And we have done this in different farms across Ireland, and we have observed the same tendency, where healthy points yield higher total mass of protein. So the drone technology will allow us to detect areas of where the plants, the crops are stressed, and that gives us the option to take interventions or modify the farming practices to make a more efficient use of resources. And also because if we can reduce those stress areas, we will have a protein level or quantity that it's less variable across the field. And that will contribute to have a more environmental and economical sustainable production. So the work that we are going to continue is now to start to compare the data that we obtain with the drone with something obtained by the satellites that my colleague George will explain you more further on how the satellites are being used for nutrient tracking. So we expect that complementing these two tools will help to find better practices, better management on the farm to optimize the protein yield. And of course, we'll also be considering all data that farmers can give about their farming practices. So that's the case study of how the drone is being utilized for nutrient tracking. And the second part is the modeling tool that we are developing. So as I said at the beginning of the presentation, it's the 3 steps: mapping the chain, collecting data, and building the model. So also, as I said before, we have mapped the whole chain of for the production of a plant-based beverage. Here I show just a simplified version of that flow chart, and we have gathered data for this supply chain at pilot plant and also by published data. And at the moment, we have a preliminary protein tracking model of this map, and we look forward. We're working forward to incorporate also the tracking of carbohydrates, fat, and carbon footprint for life cycle analysis. So I will show you like a preview of our nutrient tracking tool. So as you can see from the left, we have, in this case, inputs. We're having just something simple at the moment, meaning at the farm, the area, the hectares, and the yield that you obtain per hectare. If you can just help us to mute yourself, please. Thank you. So those are the inputs, meaning the amount that we have, but also we have a control on the protein content that we have of the crop. So as you can see, these three inputs can be easily moved around in the tool that we are developing. And based on how much you obtain in the field, we see that we can calculate automatically the yield of all the products that are produced during the supply chain, from the raw peas all the way to the beverage. And we observe also, like, depending on the protein content, how the amount of the yields of all these products change. So this is the potential of the nutrient tracking, that by observing how much the protein content change or the yield, we can foresee how this will affect to the whole supply chain. And as I said, at the moment, we are having the tracking of protein. So this is the amount of protein for each of the products of the supply chain. So it's also variable depending of the yields and of the protein content. So as I said, this is just a preview, and we will be working to incorporate more data for other bionutrients. So from my side, that's all. But before finishing, I just want to acknowledge the help of my colleagues, especially from Dr. Tryphon Kex from the National Technological University of Athens for helping in building the supply chain mapping. Also to Dr. Sheila Alves and Dr. Badra Parija from here in Teagasc that support the work on the field with the drone. And finally, to Dr. Richard Lynch, also here from Teagasc, for his help in building the modeling tool that I just showed you. So that's all from my side. Thank you very much.
Thank you, Dr. Alvarez. Now our next speaker will be presenting Dr. George Kyriakarakos. So, Doctor, you can start your presentation.
Yes, thank you very much. First of all, can you see my screen? Okay, this is really good. Today I'm excited to share with you a transformative vision in the field of agriculture, a vision that leverages digital technology to redefine sustainable farming, and of course show how this vision is realized under the scope of the VALPRO Path Project. So, transforming agriculture digitally faces a major challenge. That challenge is heterogeneous data across various resources. And this diversity leads to fragmented data, complicating effective integration for climate-smart agriculture. Such data variability hinders the efficient data analytics, which are essential for proactive farm management. And furthermore, it obstructs precision agriculture's full implementation, which relies on consistent, accurate data in order to achieve optimal resource use. So what we actually need is integrated systems able to provide holistic insights and improve the sustainability of protein production. So this is a concrete example of fragmentation, where you need a combination of a big number of software packages to address the needs in various aspects of climate smart agriculture. So starting, for example, with acquiring data through a multispectral photograph and satellite images to analyze it, and finally plant your roots or apply variable fertilization, you need usually a number of different software. You need to manually move data from one to the next, which is much less than optimal. So to revolutionize the scenario, we have introduced our digital agriculture platform, which integrates cutting-edge Internet of Things and artificial intelligence technologies. Our suite of 8 interoperable modules offers a comprehensive solution from soil health monitoring to optimized resource allocation. These tools can empower farmers to increase yields, reduce waste, and comply with ease with environmental standards. Just imagine a farmer being able to predict crop diseases before they happen or optimize fertilizer usage based on real-time data. That's the future that we are building, and for the purposes of VALPRO, we want the farmer to be able to optimize crop protein content. So our solution consists of 8 interoperable IoT AI-enabled applications for the holistic assessment of information, which is collected either in field from proximal and remote sensors, from UAVs, agri-machinery, agri-robotics, and more. Under VALPRO Path, we are developing and integrating targeted applications for protein crops. So how do we support the nutrient tracking in VALPRO Path? We provide, first of all, real-time nutrient insights. We track soil nutrient levels using advanced IoT sensors, measurements, as well as satellite data. And we recommend optimized fertilizer application, which is tailored to its crop needs. Of course, we can minimize nutrient runoff and overuse of fertilizers this way, and support the improvement of soil health, while in the long term supporting the productivity of the fields. And of course, this also has an economic impact, since it reduces input costs while maintaining or actually increasing the yields. So we have a simplified user interface. It allows farmers to use our platform even if they are not really experienced with digital tools. They get right away actionable insights like early detection of potential issues. This could include pest infestations or nutrient deficiencies. They can get tailored strategies for reducing water, fertilizer, and energy use in their farm. And of course, by the end of this project, they will be able to get crop protein content forecasts directly on their interface, on their mobile phone, probably. And this also promotes the transparency for all stakeholders involved, since it enables better compliance with environmental and sustainability standards, while building consumer trust through traceability and transparency. So far, we have 42 fields with a total area of about 110 hectares, where we monitor all cultivation data, which includes the agricultural operations, the machinery use, as well as all the inputs and outputs like fertilizer or irrigation. At the same time, for these fields, we provide support to the environmental impact assessment through the LCA that is being performed. We do some post-processing, some pre-processing of the data in our platform, building a metadata inventory for LCA, which is then transmitted to the LCA engine that is being implemented and operated by NTUA, and this eventually leads to the LCA reporting in the VALPRO Path project. And now, in terms of the actual data that you can get from our platform relevant to VALPRO Path, you can easily share a QR code, and through that QR code, you can get either on a mobile phone browser or a web browser the key tracking data from each field. I want to highlight here that all trackability data are also available through an API, which can be then utilized in other digital agriculture solutions, as well as more tools downstream the protein value chain. And of course, we are working hard to enable protein prediction. We are initiating an open source database for AI training and implementation for protein crops, nutrient tracking and prediction. How we are going to do that? The key component, which is going to be available under an open source license, will be the time series crop monitoring database. Using that database, we will train our AI and machine learning algorithms, which will essentially power the provision of data to the farmers of protein prediction through our platform. And to get into more details on how we are implementing this, first of all, through our Internet of Things suite, we are going to be collecting synthetic aperture radar satellite data, and this includes SAR dual polarization raw data and over 11 indices, including RVI, PRVI, NDPI, PI, polarization ratios, as well as composite indices. We're going to get multispectral instrument optical satellite. This raw data includes 10 bands and over 60 indices, including again some very common ones like DVI, NDMI, EVI, and so on. We're going to utilize satellite-derived digital elevation models, which essentially allow geographical and hydrological data to be included, including elevation, slope, aspect, TRI, TPI, flow direction, flow accumulation, and TWI. And finally, through meteorological stations, we're going to get climatic data, which includes temperature, humidity, and precipitation. All of this data together will form the time series crop monitoring database, which is the base for any AI tool for the prediction of protein content. We're going to implement that through our platform in VALPRO project, but also provide this data for other research groups to be able to develop their own algorithms based on it. So this is it from my part. I want to thank you for your attention, and feel free to ask any questions. Thank you.
Thank you, George. Hello, everyone. I am Anna Stefanović, Communication Dissemination Manager for the VALPRO Path Project, alongside my colleague Dušan Čenejac. First, let me thank you to speakers, Ricardo and George, great presentations. Before we open the floor for the Q&A session for our attendees, I have a few questions I'd like to ask you both. The first question for Ricardo. How does your systems modeling approach improve the accuracy of nutrient tracking, particularly protein, across the plant-based food supply chain compared to traditional methods?
Yeah, thank you, Anna, for that question. So yeah, as I was explaining, the utilization of advanced technologies such as the drones, NIR sensors, satellites, helping us to obtain data in a more fast way compared to traditional methods, which usually you rely on taking the sample to the lab, preparing the methods, and obtaining a result. So these new tools help us to obtain results in a faster way, to make decisions also faster. So by using almost like we can say enable real-time data we can do the adjustments in the field that are necessary to improve the amount of protein that can be obtained from the fields. I don't know if that's answers your question.
Yes, thank you very much. The question for George, what are the key barriers to adopting digital tools for nutrient tracking and plant protein systems, especially for small-scale producers?
Okay, thank you for the question. And indeed, one of the most significant challenges to adopting digital agriculture solutions in general, and in particular for protein tracking, especially among small-scale farmers, is the high initial cost and limited access to technology. Financial constraints can often make it very difficult for small farmers, especially to invest in advanced digital tools or IoT devices. And this issue is compounded by inadequate infrastructure, such as unreliable internet connectivity in rural areas, which further impedes the adoption. As I have mentioned in my presentation, is the complexity caused by the use of many digital platforms. And many of these tools are frequently perceived as too complicated or just simply not user-friendly, especially by farmers with limited technical knowledge. The lack of accessible training or ongoing support services further complicates things and leaves farmers unable to fully leverage the potential of these new technologies. The fragmented nature of the data ecosystem again poses a significant hurdle, as I explained in my presentation. Many times farmers rely on multiple tools, and integrating some of the tools they used in the past with some newer tools can be both challenging and time intensive. And unfortunately, many times we have the prevalence of data silos, which prevents seamless information exchange across different systems and platforms. Generally speaking, of course, cultural and behavioral factors add another layer of complexity. In different parts of Europe, you can find resistance to change, especially among older farmers, which are accustomed to traditional practices. And we have seen that this slows down the adoption of digital tools. And added to that, there is skepticism about the reliability and actual benefits of using these technologies. Finally, sometimes you get inconsistent policy frameworks, and the market incentives are not always optimally designed. And many times, to be honest, these incentives can be clearly missing. And this leaves the small-scale farmers with very little motivation to prioritize digital tools. I guess this is much or less the challenges faced. Thank you very much.
Thank you. The next question for Ricardo. Can you elaborate on how advancements in crop nutrition data analytics are shaping decision-making for producers and consumers in the plant-based food sector?
Yeah, thank you for the question. I think this is related to the modeling tool that I showed during the presentation. So we, by understanding the data across the processing of a plant-based product, processors can identify where their process can be optimized in a level that doesn't sacrifice the cost of producing. So finding the balance of optimization, but not increasing their cost. Also, it is telling us the amount of nutrients that are lost in the side streams. So by producing revalorization of those side streams, we the processor can get an additional benefit on that, and it will not only be benefit of the producer, because that translates also to how the consumer can perceive that we live in nowadays in a time that consumers are want to know more about how their products that they consume they are processed. So the tool can be used to provide information to producers on telling the consumers how sustainable are the production systems on the products that they are consuming. So using this data modeling by the producers can help lower environmental footprints that align with the consumer demand of eco-friendly products.
Thank you, Ricardo. And the last question from my side for George. Can you share specific examples of how the platform has improved nutrient tracking outcomes for users in real-world scenarios?
Okay. So far, under VALPRO, we have primarily focused on building a robust data foundation by logging comprehensive field and cultivation data, as well as operations data from these fields. Keep in mind that these fields are real fields farmed by real farmers and not experimental fields, which means that we have undertaken concurrent capacity building of the farmers in the digital tools use in order for them to be able to log in information, see the information that's available to them through the platform, and so on. So far we have integrated various data sources, which include IoT sensors, satellite imagery, and climatic data, which help us create time series of crop monitoring stored in a database that is tailored to protein crops. Although we are not yet at the stage to share specific data in terms of before and after comparisons and so on, the groundwork we are currently laying is critical for the future advancements as I have presented them before. For example, the VALPRO Path under VALPRO Path, we are going to utilize this data for nutrient tracking and also for predicting the protein content. Also, real-time insights are already available to the farmers in terms of soil nutrient levels, and of course, we are providing support on optimal fertilizer application. The long-term goal of using a platform as the one offered by farmB in this project is to enhance both sustainability and productivity by minimizing nutrient runoff, improving soil health, and optimizing, of course, the protein content. As I said, one very promising aspect of our approach, since we are currently working on it and we're very excited, is the integration of AI in our system in terms of realizing predictions. Based on the current progress, I can say that I believe that we are going to get a very good indication and forecast of protein content. At the same time, we are very happy that we will be able to share with other research groups the open source database we are building, which will support even further and broaden the protein crop sector, since data is always needed if you're going to develop any AI application, and lack of such data is one of the major barriers into developing such tools. We are really happy and excited, and we hope that during one of the upcoming webinars we'll be able to present more updates in terms of the progress made, and especially the AI prediction tool. Thank you very much.
Thank you, George. So we can now open the floor for questions. You can write them in the chat or in the Q&A section. we can wait a few minutes to see if someone has some question for our speakers. Okay, we don't have any questions. Therefore, I would like to give a floor to my colleague Dušan.
Okay, thank you, Anna. And yes, great presentations, great answers. I would like to thank George and Ricardo for being a part of our fourth webinar in our VALPRO Path webinar series. I want to thank everybody for attending and participating in the webinar. As we said, we have been recording the webinar and we will be sharing through our VALPRO Path social media channels. So if you haven't yet, please follow them. As we have a LinkedIn, YouTube, Twitter, and Facebook. You can always visit our website. That's the VALPRO Path, VALPRO Path EU. We have made a QR code here for easier access, so you can scan it and it will take you directly, and you can find out more about our project. Once again, thank you everybody for attending. Thank you to the speakers, and we wish you a pleasant day. Goodbye.